All right, I want to go through the investigation here. I'll do some of this on this sheet, and I've got a piece of notebook paper over here as well. There are also some good calculator things that some of you may not know or may have forgotten. So Forrester asks us to make a sketch of D versus T. Remember, anytime you're talking about rates, you're comparing two things. So we have time and seconds on this axis. We have D, which is degrees. And in this picture here, we don't actually know how far the door opens. In the example I did, the door opened to a little more than 90 degrees. So, you know, maybe you're going to have it open to like 120 degrees or something like that. So if you read it carefully, it says at time equals 0, somebody pushes the door. It was shut and it swings open, okay? So at time 0, the door is 0 degrees open. So I'm going to plot the point 0, 0, okay? And then the door kind of swings open, okay? It says it slows down, stops, starts closing, and then slams shut, okay? So it sounds like it opens very quickly at the start. So I would probably have something, again, you know, fully open is going to be maybe about 120. So maybe something kind of increasing like that. And then it swings open, slows down, stops. So I do have it kind of slowing down, maybe a little bit around 120 there. Starts closing, and then it says it slams shut. So, you know, I'm thinking it's going to do something very quick. It'll drop off fast. Maybe it'll drop off even more steeply than that because it slams shut, okay? And again, I'm just thinking about different points here. So, you know, maybe you're 5 seconds in here and the door is, you know, starting to close. You can think about different points, different times, and how many degrees you think the door would be open, okay? Part 2, Forrester asks you to graph this on your graphing calculator. So I've put this in the calculator already. You can see that the y equals button here. Obviously, you have to use an x instead of a t variable here, but it shouldn't be a big deal. Now, if you just graph it with your standard window, you're going to get something that looks like this, which obviously does not look anything like that, okay? Keep in mind, anytime you make a graph, your calculator has no idea what you're trying to graph. You need to set up a window that matches your data. So actually, if you did a little bit of labeling in your diagram over here, maybe the door will take 5 or 10 seconds to open, total. That's what's on this axis. Maybe it's going to open to a little bit more than 90 degrees, so you probably want your degrees to go a little higher than 90. So I would go to the window, and I would manually set this up, okay? If you try to do some kind of automatic thing, your calculator's got no clue. So I'd like my x-axis to go from 0. I have 5 in this picture, but I'm going to do more like 7 or something. 0 to 8 seconds, let's say. And then we come down here, and the y-axis is going to go from 0 to 120, or maybe 0 to 130, something like that. Okay, there we go. And anyway, we can go ahead and run this, and let's see what the graph looks like. This is interesting, by the way. If you notice, it actually kind of levels out here. It actually looks like it doesn't slam shut in his graph. It kind of looks like it slowly closes, which is interesting. Okay, next part, he asks us to make a table of values. I would just run a table. I wouldn't stick this in the equation every time. So I'll go up here to table set. I want my table to start at 0. I want it to count by ones. And I'm going to leave this on auto, so it'll just give me a table just automatically counting. So I'll hit second, go to table here, and you can see that. Now, I'm going to start filling some things in here. So we've got 0, 0, we've got 1, 100, and so on. One thing you do need to be careful about, sometimes when you have decimals, you can't see the entire screen. Like, for example, if you notice this one here goes a little bit off the screen. Down here you can see a longer version of the decimal, but the column will kind of cut it off. That may come into play somewhere else, okay? If we go to number 4, it says t equals 1, does the door appear to be opening or closing? How can you tell? Well, let's go back and look at the graph, and you can see here it hits a maximum number of degrees here, and the degrees are dropping. So at 1 second, you can see that it has not hit the maximum yet. So the graph is still increasing. That means the angle is still getting bigger. So the door would be opening at that point, okay? Now, part 5. We want to find the average rate at which the door is moving on the time interval from 1 to 1.1, okay? So remember, average rate of change is really a slope, okay? change in y over a change in x. So what we're really saying is, on our graph here at 1 second, about what would the slope be right there. And Forrester's saying, let's pick some points that are really close together. Let's look at a point at 1 second and a point at 1.1 seconds. So he's picking a point here, and we're picking a point like really close to that, and we're trying to figure out what that slope would be in there. And remember, the slope is telling us the rate of change in degrees per second that the door would be moving at that moment in time. So we're using the average rate formula, but we're really using it to estimate an instantaneous rate, okay? Because at an instant, we're going to get a pretty good guess as to what this is going to be, okay? So I want the point 1, if you look at my table down here, 1 comma 100. At 1 second, it's 100 degrees open. And I'm just going to go run my table here for 1.1. So I'll go up here and I'll start my table at 1.1. Or you could put it in ask mode, and you see this value right here. Be careful, it's not 102.63. It's 102.633362, so on. Okay, I would go several decimal places out, and you're going to see why in just a second. Okay, so back here, so we're trying to find the slope between those 2 points on this graph, okay? So slope, of course, change in y over change in x. Now remember, your book is going to say f of b minus f of a. You're subtracting 2 y values, and you're subtracting 2 x values. They're going to use slightly different notation, but it's the same thing as the slope you did in Algebra 1. So we're going to do 102.633629 minus 100. And on the bottom, we're going to do 1.1 minus 1. And you're going to be left with about 2.633629 over 0.1. When you divide by 0.1, that's going to roll the decimal place one place. It's going to be about 26.336. And watch your units. We have degrees in the numerator. We have seconds in the denominator. So it's degrees per second, okay? Your y unit's always on top, and your x unit's always on the bottom. Okay, now Forrester's going to ask you to do the same thing here, except you're going to use a point at x equals 1 and x equals 1.01, and then one at 1 and x equals 1.001. You're going to keep getting values that are pretty close to that value of 26 point something, okay? But as you start to pick values that are closer and closer together, you're going to get increasingly accurate answers. So I may not go through this whole thing here, but that's the general concept. So I'll do just a little bit more here. So we've got the point 100, and I'm going to go back to the table and look at it at 1.101, and that's going to be about, and remember to look at the full decimal there. So that's going to be 1.01 comma, and it's about 100.30234. Okay, so same thing here. We're finding the slope. So f of b minus f of a, or we could say it's f of 1.01 minus f of 1 all over 1.01 minus 1. And anyway, when we subtract those 2 y values, we're going to be left with 0.30234. When we subtract the x's, 0.01. Divided by 0.01 is going to roll the decimal 2 places. It's going to be about 30.234 degrees. Okay, so a little bit bigger than that. This is a little more accurate because we picked points that are a little bit closer together on the curve to estimate our slope. All right, so that's the basic idea. And then Forrester's going to have you try this one. And again, I think you're going to get a value also close to 30. The idea here is you're approaching what's called a limit. You're getting closer and closer and closer to the actual slope at that point on that curve. All right. So hopefully that kind of gives you a little bit of clarity and makes this start to come together a little bit more for you.